We don't really think about it this way, but your computer, it's not just a machine. It really has a life cycle. It's got a beginning, a middle, and, well, an end that can be rewritten. Today, we're going to walk through that entire journey, from its birth to its daily battles, and even its rebirth after a disaster. So let's ask the big question right up front. What does it really take to keep your computer not just running, but safe and sound? It's a lot more than you might think, covering everything from the moment you set it up to how you bring it back from the brink. Let's dive in. All right, every story has a beginning, and for your computer, that's its birth. This first stage is all about laying down a super solid digital foundation, and trust me, it's way more than just pulling it out of the box and plugging it in. Think about it like building a house, right? If you mess up the foundation, you're going to have problems forever. It's the exact same idea in the digital world. A really well-planned setup from the get-go is absolutely critical for the long-term health of your system. So what does this foundation actually look like? Well, it's kind of like a three-layer cake. First, you've got the physical hardware. On top of that, you install the operating system, the brain of the operation. And then finally, you put on all the software you actually use. Each layer completely depends on the one below it. If you make a mistake here, you could be building in a weakness before you've even started. And take a look at this. It might just look like some boring technical window, but this shows you exactly what I mean. This is the shrink volume tool in Windows, which you use to create different sections or partitions on your hard drive. This isn't just a random click. It's a strategic decision about how you're going to organize your system space, and that choice can have big consequences later on. And that's really the key takeaway for this first stage. Every little decision you make during this birth, from partitioning a drive to installing the right driver, goes into building that foundation that has to support everything else. Okay, so the system is born. It's up and running. Now its real life begins. And just like out here in the real world, that means facing threats every single day. So that brings us to our next phase, building its defenses. I love this quote from the Washington State Auditor's Guide. It just nails it. Cybersecurity is everyone's job. It's not some far-off concept for the IT department to worry about. It's a daily habit, a responsibility that falls on every single one of us who uses the machine. That's a great saying and all, but what does it actually look like for you or me on a normal Tuesday afternoon? It's actually about the simple, small stuff, the repeatable actions. For example, you download a file, and you're not totally sure about it. All it takes is a quick right-click and hitting Scan with Microsoft Defender. That tiny moment of vigilance, that one little habit, that's you doing your part. That's you contributing to the system's immune system. A system that doesn't change, a system that doesn't adapt, quickly becomes a vulnerable one. And that leads us right into the next stage of its life, growth and maintenance, or as I like to call it, the constant tune-up. So why do we get all those constant, kind of annoying notifications to update our software? Well, this slide lays it out perfectly. Updates aren't just about getting cool new features. They are literally preventative medicine for your computer. They fix bugs before they crash your system, they patch security holes before hackers can find them, and they just keep things running smoothly. Now, when we say updates, it can mean a couple of different things, and it's pretty important to know the difference. You've got firmware, which is basically code that lives on the physical hardware itself, like on your motherboard. Then you have a device driver, which is software that lives on your main hard drive and acts like a translator between your operating system and that piece of hardware. Both are super important, and both need to be kept up to date. And don't for a second think this is always just a simple click here to update kind of deal. Check this out. This flowchart shows the kind of strategic thinking that goes into deciding how to apply updates in a professional IT environment. Is the OS installed? Is it online? Each answer takes you down a different path to a different tool. Maintenance is a really thoughtful process. So, you can do everything right. You can build that perfect foundation, you can defend it every day, and you can maintain it like a pro. But in the life of any computer, a crisis, it isn't a matter of if, it's a matter of when. It's a pretty stark reality, isn't it? The threats are just constant, and they come from everywhere, from inside the system itself, and of course from the outside world. And here they are, the usual suspects. This list pretty much covers it all. You've got everything from the accidental stuff, like a hard drive just giving up, or someone making a mistake, to the really nasty, malicious things like theft, malware, and the one everyone dreads, ransomware, that literally holds your digital life hostage. A crisis like that,
It can feel like the end of the world, but it doesn't have to be. And that brings us to the final, and maybe the most important stage in a computer's life, the comeback, the rebirth after the disaster.
See, while we can't stop every single disaster from happening, we can absolutely prepare for them. And having a really well thought out recovery plan is what separates a minor headache from a total catastrophe. And at the very heart of any great recovery plan is a simple, powerful, and really easy to remember rule. It's just 3 numbers. 3, 2, 1.
So what does 3-2-1 mean? It's brilliant in its simplicity. You need to have 3 total copies of your important data. Those copies need to live on 2 different types of media. So, for example, your computer's internal drive and an external hard drive. And here's the most critical part. One of those copies has to be stored off-site, away from your computer. That protects you from physical disasters like a fire or a flood.
So the 3-2-1 rule is the what you need to do. This side here shows you the how. A real deal recovery plan is built on 3 pillars. First, you need a policy that sets your goals. Second, you need a strategy for how you're going to actually do it, like how you'll implement that 3-2-1 rule. And third, you need a documented plan, clear, step-by-step instructions so anyone can follow them when things go wrong. And that brings us right back to where we started. A careful birth creates a strong foundation. Daily defenses and constant tune-ups preserve it. An inevitable crisis will test it, but a well-prepared comeback ensures its rebirth. That's the whole cycle, right there. Look, this isn't just about a box of circuits and wires. This is about your data, your work, your photos, your memories. Your entire digital life follows this very same cycle. All right, let's talk about that box on your desk. You use it every day, but what is actually happening inside? We're going to crack it open and show you the secret game that's always being played, from the moment you hit the power button to when you're browsing online. And trust me, by the end of this, you're going to know all the rules. You know the feeling, right? We have all been there. You get a brand new, shiny webcam or a printer, you plug it in, and crickets. Nothing. It's super frustrating, but the reason it happens is actually pretty cool. So the absolute best way to get your head around how all these different computer parts work together is to imagine it's all just one big, elaborate board game. Seriously, there are pieces, there's a rule book, and there are even instructions printed right on the board. Once you see it this way, everything else is going to just click into place. Okay, so first things first. Every game needs a board and some pieces to play with, right? Well, in the computer world, that's what we call hardware. Hardware is simply all the stuff you can physically touch. It's your laptop, your monitor, the mouse, the keyboard, even the cables. In our game, this is the board itself, it's the little player tokens, the dice, all of it. It's the tangible stuff you have to have before you can even think about playing. But what good are a bunch of pieces without any rules? That's where software comes in. If the hardware is the game board, then the software is the rule book. It's the list of instructions that tells all those physical pieces what to do and how to do it. Think of your operating system, like Windows or Mac OS, and all your apps. They are literally the rules that make the game playable. And then there's this third kind of special category. It's called firmware. It's software, but it's permanently built right into the hardware. You can think of it like the instructions that are printed directly on the game board. You know, things like start here or go back 3 spaces. It's always there, and it handles the most basic, essential stuff the second a device is turned on. So we've got our board, we've got our pieces, and we've got our rulebook. But what happens when you try to add a new piece to the game, one that didn't come in the original box? Well, that's where things can get a little interesting. And this brings us right back to that classic problem. You buy a new printer, but your computer, your main game board, it doesn't have the specific rules for that printer in its main rulebook. Your operating system knows all about keyboards and mice, but this new gadget, to the computer, it's a completely foreign object. So what do you need? You need a translator. And that is exactly what a device driver is. It's a special little program that acts like a helpful friend who knows all the rules for the new piece you just added. It translates what the printer is saying into a language the computer understands and the other way around. Without that driver, they just can't talk. It's as simple as that. And luckily, giving your computer this little translator is usually super easy. You just figure out what the new device is, pop over to the manufacturer's website, look for a support or downloads page, find the right driver for your computer, and run the installer. Sometimes you have to do a quick restart, and bam, that's it.
Your computer now knows all the rules for its new toy.
All right, so all our pieces are on the board, and now they all know how to talk to each other. So how do we, the player, actually play the game and keep track of everything? Well, that's where our command center comes in, the operating system.
Your operating system is basically the game master. It's in charge managing everything and making sure all the rules are followed. And the main tool it gives you to look around and manage your stuff is the File Explorer. Just think of it like your inventory screen in a video game, where you can find, organize, and use all your digital items. And this whole command center is designed to make your life easier. For example, pinning a folder to quick access is like putting your favorite game piece right where you can grab it instantly. The share button lets you pass your files to other players in a click. And the search bar? That thing is amazing. It lets you find any item you need, doesn't matter if it's on your computer or saved up in the cloud, it's all right there.
Okay, so up until now, our little board game has been its own self-contained world. But the real magic happens when you connect your game to a global network of millions of other games. Let's talk about getting online. Now, plugging your game into that worldwide network can happen a few ways. Way back in the day, there was dial-up, which was painfully slow, and you couldn't use the phone at the same time. These days, most of us have broadband, like DSL or cable, which is way, way faster. And if you live somewhere really remote, satellite internet can beam a connection right down from space, though, a big storm can mess with it sometimes. To actually make that connection, you need two little boxes. First is the modem. Think of the modem as the front door to the internet. It's what talks to your internet provider. Then you've got the router. The router takes that one internet connection and creates your own personal Wi-Fi network, sharing it with your phone, your laptop, your smart TV, all your devices.
So our game is now connected to the entire world, which is awesome, but it also means we've opened the door to some things we'd rather keep out. So the very last layer we have to add is a really good defense system.
And that's where antivirus software comes into play. To put it simply, it's a program that acts as your computer's immune system. Its entire job is to stop malicious software or malware from getting in and to find and destroy anything that manages to sneak past the gates.
And it has two main ways of doing this, which is pretty clever. The first way is called signature-based detection. This is like having a giant photo album of known criminals. It scans for the digital fingerprints of viruses we already know about. The second method is heuristics. This is more like detective work. It looks for suspicious behavior to catch brand new viruses that nobody has ever seen before. And that's absolutely crucial.
And why is that detective work so important? Because the scale of this is just mind-blowing. Antivirus companies can find over 500,000 new, unique pieces of malware every single day. Just let that sink in. That's why having a solid defense system isn't just a suggestion. It's totally essential if you're going to be online today. So there you have it. You've got the physical game pieces, the hardware, the instructions printed on the board, the firmware, the translators for new pieces, the drivers, the main rulebook and game master, the software, and finally the shields up for protection, your security. It's a lot of layers, but they all work together perfectly to give you that smooth experience you expect every day. So next time you plug something in and you have to find a driver, or your antivirus sends you a little notification, you'll know exactly what's going on behind the curtain. You get the game now. So the only real question left is, now that you know the rules, how is that going to change the way you play?
Your computer is constantly trying to talk to you. It's sending all these little signals about what it means, what's working, and what's not. But most of the time, we totally miss the message. So what if you could learn its secret language? Well, today, we're going to decode the essentials of PC maintenance and turn all that digital confusion into crystal clear understanding.
We've all been there, right? It's that moment. You plug something in, you click an icon, you expect something to happen, and you get nothing. Or even worse, you get some bizarre error message. It is one of the most common frustrations of modern life, but what's really going on behind that screen?
Yeah, I'm sure these look painfully familiar. A driver cannot load. Code 39. It feels like the computer is speaking in some ancient, forgotten code. But really, these are just symptoms of a simple communication breakdown. It's basically the digital version of a crossed wire. And today, we're going to untangle it.
Honestly, the best way to think about your computer is as a living, breathing ecosystem. You've got the physical world, all the hardware you can actually touch, and then you've got the digital world of software. And for anything to work, these two worlds have to be in constant, perfect sync. When they're not, that's when you get those frustrating error messages.
All right, so let's start our journey on the physical side of this ecosystem. We're talking about the things we can actually see and touch, the plugs, the ports they connect to, and all those accessories or peripherals that bring our computers to life. So what in the world is a peripheral? It's actually super simple. It's just any piece of hardware you connect to your computer to get information in or out. You know, think about your keyboard, your mouse, your printer, your webcam. They're basically the hands, ears, and voice of our digital world.
Now, connecting all these things usually means dealing with a whole sea of cables. It can look like a total spaghetti monster behind your desk, but it's simpler than it seems. This little chart breaks down the big four. USB is your jack of all trades for data and power. HDMI is what you'll usually use for your TV or monitor. DisplayPort is kind of similar, but you see it a lot on high-end computer monitors. And then there's good old Ethernet for that rock-solid wired internet connection.
And you know, the speed of these connections has just exploded over the years. Just look at USB. Back in 1996, we were moving data at a pretty slow 12 megabits per second. Fast forward to today, and we're hitting speeds of 80 times gigabits per second. That is nearly 7,000 times faster. It's an absolutely incredible leap that shows you just how much more we're asking of our physical connections these days. Okay, so we've got the physical connections down. But plugging something in is only half the battle. How does your computer actually talk to the thing you just connected? Well, that's where the real unsung hero of our story comes in, the device driver. Think of it as the invisible digital handshake that makes everything possible.
So what is a driver, really? The easiest way to think about it is as a translator. It's this little piece of software that takes a signal from your hardware, like you clicking your mouse, and translates it into a language that your operating system, like Windows, can actually understand. Without the right driver, your hardware is just, well, a useless piece of plastic and metal. Let's trace that whole translation process for a second. Imagine you press the letter A on your keyboard. That physical action sends a little electronic signal. The keyboard's driver catches that signal and immediately translates it, telling the operating system, hey, the user just pressed A. The OS then shoots that command over to whatever program you're using, and boom, the letter A pops up on your screen. This all happens instantly, thousands of times a day, all thanks to that little driver working tirelessly behind the scenes.
So that kind of begs the question, where do these super important translators even come from? Well, most of the time, Windows is pretty smart and just finds and installs them for you automatically through Windows Update. For more specialized gear, you might have to pop over to the manufacturer's website and grab it yourself. And of course, a ton of basic drivers for things like keyboards and mice just come pre-installed right out of the box. Okay, now that we understand the physical and digital connections, how do we keep this whole ecosystem healthy? Just like anything else, a computer needs a bit of regular care to perform at its best. This is all about your digital hygiene routine.
You know, one of the best things you can do is just reduce the clutter. Over time, we all install software that we stop using, and it can really slow things down. Uninstalling it is super simple and totally safe. Just go to your control panel, find Programs and Features, pick what you want to get rid of, and click Uninstall. It's such a quick way to free up space and stop potential software conflicts.
And here's another crucial maintenance step, running a regular security scan. It's built right into Windows, and it couldn't be easier. Just open up Windows Security, head over to Virus and Threat Protection, and click Quick Scan. This will check for any nasty software that could be messing up your computer's ecosystem and helps keep all your data safe.
But what happens when, even with all your best efforts, something still goes wrong? First off, don't panic. Let's build a basic first aid kit for those PC problems that are bound to pop up. A little bit of troubleshooting knowledge goes a really long way.
When things start acting up, the very first thing you need to do is put on your detective hat. You need to ask one simple but crucial question. Is this a software problem or is this a hardware problem? Figuring that out is honestly half the battle because it tells you exactly where to focus your attention. And this really breaks down the two different paths to take. If you think it's a software issue, like say a single program keeps crashing, you start by restarting that program or maybe even your whole computer. But if it's a hardware issue, like your mouse suddenly stops working, your first move should be physical. Check the cable, try a different port, make sure it's plugged in all the way. This simple split helps you track down the problem logically. Okay, let's talk about one of the most mysterious computer problems out there. You open up your device manager to investigate something, and there it is.
that dreaded unknown device with the little yellow warning icon next to it. What is it? How do you fix it? It feels like a complete dead end.
But there's a secret key to unlock that mystery. This is a total pro-level trick that lets you identify any piece of hardware, but it's actually super easy. In Device Manager, just right-click that unknown device, go to Properties, then click the Details tab. From that drop-down menu, pick Hardware IDs. Just copy that pop line of text, paste it into Google, and I promise you, you will find out exactly what that device is and where to get the right driver for it.
Seriously, this trick is an absolute game changer. It puts all the power back in your hands. No more guessing, no more getting frustrated. You can now identify any component in your system and find the exact piece of software it needs to do its job. This is how you solve those problems that feel totally impossible. So when you pull it all together, from the cables we plug in to the drivers that translate every single command, our computers are in this constant state of conversation. It's this beautiful, intricate ecosystem of hardware and software speaking a secret language. The real question is, now that you know the basics, are you ready to listen? Upgrading your PC's operating system, making that jump to something like Windows 11, it can feel a little bit like you're about to perform surgery. It seems complicated, maybe a little risky, but honestly, with the right preparation, it can be a totally smooth and, believe it or not, a pretty straightforward process. So let's walk through how to get it done right. We're going to break this whole journey down into 5 key stages. We'll start at the very beginning, with how your computer boots up. Then we'll run a little pre-flight check on your hardware. After that, and this is a big one, we'll create your digital safety net. Then you've got a decision to make. And finally, we'll talk about what to do once the new OS is up and running.
So to really get this, we have to start before Windows even shows up on screen. That very first moment you hit the power button, something really fundamental is already happening under the hood. See, before your operating system can even think about loading, this special piece of software that's built right into your motherboard, it's called firmware, it has to wake everything up. For decades, that firmware was called BIOS, but modern PCs, and especially an OS like Windows 11, they rely on its much, much more powerful successor, UEFI. And that difference, that's the key to a successful upgrade.
To see why this change was so important, you just have to look at the old system's limits. The old BIOS used a thing called MBR, which physically could not handle a boot drive bigger than 2 terabytes. Now, back in the day, that seemed enormous, but today, that's a huge roadblock. UEFI, on the other hand, uses a modern system called GPT, which can handle drives that are massively larger, and it's just way more robust. But UEFI isn't just about big hard drives. It also gives us way faster boot times and, this is the big one, enhanced security features like Secure Boot. What that does is it makes sure no malicious software has snuck in and hijacked your boot process. And here's the kicker. For Windows 11, this isn't just a nice-to-have. Having a UEFI system with Secure Boot is a mandatory, non-negotiable requirement. All right, so now that we get the whole firmware foundation, let's run a quick pre-flight check and see if your PC meets all the other requirements for Windows 11. Now, most of these hardware specs are pretty standard for any computer made in the last few years, but there are a couple here that often trip people up. We've already talked about needing UEFI and Secure Boot. The other one is TPM, or Trusted Platform Module version 2.0. This is a little security chip that handles hardware-level encryption. And yep, it's another one you absolutely have to have for a Windows 11 install.
So if you run Microsoft's PC Health Check app and it tells you your PC isn't compatible, don't panic. A lot of the time, it just comes down to a simple setting. So many PCs actually ship with UEFI and Secure Boot turned off by default. You just need to restart your computer, jump into the system setup, the firmware settings, and flip the boot mode from BIOS or Legacy over to UEFI, just like you're seeing here.
Okay, before we go a single step further, we need to talk about what is, without a doubt, the single most important part of this entire process. We are going to create a complete backup that can save you from any disaster, big or small.
This quote from Tom's Hardware just nails it. A system image backup, it's not just a copy of your files. It's a perfect bit-for-bit clone of your entire system drive. Think of it like a time machine. If that upgrade goes sideways for any reason, you can use this image to put your computer back to the exact state it was in before you started, all in one shot. And creating this backup is super straightforward. It's basically a 4-step process. First, grab a modern, reliable backup tool. Second, plug in a fast external drive to save the image to. And speed really matters here. A modern SSD can get this done in minutes instead of hours. Third, and this is absolutely critical, create your bootable rescue media. That's the USB drive you'll use to boot the computer if Windows can't. And finally, when you run the backup, make sure you tell it to capture the entire drive, all those little system partitions included. Okay, a quick but very, very important warning. You might dig around in the Windows control panel and find an old tool called Backup and Restore Windows 7. Do not use it. Seriously, Microsoft has even said it's an old, outdated tool that's known to be unreliable and often just fails on modern Windows 10 and 11 systems. Just steer clear. Okay, your safety net is in place. You are backed up and you are ready to go. So now you've come to a fork in the road, and you have to decide how you want to install the new operating system. You've basically got two choices. The in-place upgrade is the easy button. It installs the new OS right on top of your old one, and it keeps all your files, your apps, your settings, everything. It's fast, but it can sometimes bring old software junk or weird problems along for the ride. Then there's the custom install, which most of us call a clean install. This gives you a totally fresh start for the best possible performance. And I know it sounds drastic, but Windows has this really clever trick to make sure your personal files are safe, even when you're wiping the slate clean. Here's how it works. When you do a clean install, Windows doesn't just nuke everything. It carefully gathers up your entire old Windows installation, all your personal folders like documents, pictures, your desktop, and it packs them all into a single folder called windows.old. So you get a fresh, factory new operating system, but all your important data is safely tucked away for you to grab later. So the installation is done, your computer reboots, and you're looking at a brand new login screen. Now what? Well, let's look at the two most likely outcomes, a roaring success or an unexpected error message. Let's start with a happy path. Everything went perfectly. The new OS is running great, but if you did that clean install, your desktop is empty, your documents folder looks bare, don't worry. Your files are safe and sound, just a few clicks away. Getting your data back is actually super simple. Just open up File Explorer, head over to your C drive, and open up that windows.old folder. Inside there, you'll see the familiar users folder, and inside that, your old user profile. All your personal data is sitting right there, ready for you to copy over to your new folders. Okay, but let's talk about the other scenario. What happens if the installation fails? The computer reboots, but instead of that nice new desktop, you get a nasty error message saying the installation couldn't finish. You might see an error code that looks something like this one, 0xC1900101. Now, this is a really generic code that Microsoft says usually points to a device driver problem. Basically, some piece of hardware in your computer, maybe an old printer, maybe a network card, has a driver that just isn't playing nice with a new version of Windows, and that causes the whole upgrade to fail and roll itself back. And this is the moment. This is exactly why all that prep work was so critical. Instead of spending hours trying to figure out some tricky driver issue on a computer that won't even boot properly, you can just grab your rescue USB drive, boot from it, and restore that perfect system image you made earlier. In like 10 or 15 minutes, your PC is back to exactly the way it was, completely unharmed. That backup, it's your ultimate undo button. So when you get right down to it, by understanding the tech from UEFI all the way to system backups, you've taken control. You're not at the mercy of some complex process anymore. You have the knowledge to prepare, you've got the tools to get it done, and you have a safety net to catch you if anything goes wrong. You're in charge of your own digital world. The only question left is, what are you going to build with it? You know that feeling, right? You get a new phone, or maybe you just update the software, and you open one of your favorite apps, and it's a total mess. Stuff is overlapping, the layout's all wrong, or it just flat out doesn't work. It's so frustrating, and it happens to all of us. So we're going to dig into exactly why that is. So yeah, what's the deal? How can an app work perfectly on your phone, but be a complete train wreck on your friend's device, even if you're both on Android or both on iOS? The answer is this huge, kind of invisible challenge that every single app developer is up against. It all starts with just sheer scale. I mean, think about it. There are over 4.4 billion smartphone users around the globe. That's billions of people, and every single one of them has a slightly different setup, expecting every app to work flawlessly. And here's where it gets really crazy. If we just look at the Android world for a second, there are more than 24,000 different distinct models of devices. That's not 24,000 individual phones, that's 24,000 unique models, each with its own screen size, its own processor, its own memory. It's a minefield for developers. And it doesn't stop with our phones, right? In the US, the average household has over 21 connected devices. You've got your laptop, your tablet, your smart TV, your watch. I mean, the list goes on. And every single one of them is another potential place for an app to just break.
So this brings us to the heart of the problem, what the industry calls device fragmentation, but what we can just think of as this wild, chaotic world of devices. This massive variety is the number one reason why making software is so incredibly hard.
And this quote from TestDev Lab just nails it. They say that diversity is unimaginable. You really have to let that sink in. Every single combination of hardware and software is a new test case, a new potential point of failure that a developer has to think about. And this isn't just some minor tech headache. Now, the stakes for getting this right are incredibly high. For businesses, a bad experience is a disaster. Just look at this. 40% of users will probably never come back to a website or an app after just one bad experience. So for these companies, this isn't an option. It's about survival. So how in the world do developers even begin to fight back against this chaos? Well, they have a secret weapon. It's a process designed to bring some order to this digital madness, and it's called compatibility testing. So what is it really? Put simply, compatibility testing is just making sure your app plays nicely with all the other kids in the sandbox. It's a whole process to ensure that the software works across all those different devices, operating systems, and web browsers we talked about. It's all about answering one simple but crucial question. Are we building this thing the right way? This image here shows you exactly what I mean. On the left, you've got an app like Facebook. It's been tested to death, so it works pretty much everywhere. On your Mac, your Android phone, your Windows PC. But on the right, that's what happens when you don't do that testing. You get software that's stuck on one single platform, which is a huge problem in today's world. And the list of things they have to check is just enormous. We're talking hardware, like different processors and amounts of RAM, software, like does it work on Windows 10 but not Windows 11, mobile for iOS and Android, even the network, will it work on a slow connection? And of course, all the different web browsers like Chrome, Firefox, and Safari. It's a lot. To make sure that software is actually ready for you and me, it has to go through something you could call the testing gauntlet. It's this super rigorous multi-stage process designed to find and squash all those bugs before they ever get to us. Big companies, like Dell for example, have this process down to a science. It's a whole framework. They start with basic tests in a controlled lab, then they move to a staging environment that's basically a clone of the real world. After that, it gets validated, sent to a small group of real users, and only after all of that does it get deployed to everyone else. Now, this chart might look a little intense, but it shows just how complex even one of those steps can be. See, to test an app on old systems like Windows XP, Vista, and 7, engineers don't need 3 different computers. No way. They use powerful software like VMware to run multiple virtual computers all on a single machine. It's like having a bunch of different PCs living inside one box. It's an absolutely crucial trick for testing efficiently. All right, so what are these testers actually looking for during this whole gauntlet? Well, they're hunting for bugs, of course, but specifically, they're on the lookout for all those weird visual glitches and errors that make an app feel broken. And you know what? The most common problems they find are user interface or UI issues. These are the bugs where technically the app might be working behind the scenes, but to you, the user, it just looks wrong. And let's be honest, if an app looks broken, it is broken. Here is a perfect example. On the left, you see a nice, clean login screen. Everything's where it should be. But on the right, this is what happened when it was tested on a different device. It's called an overlap issue. The text and the boxes are all smashed together. The app is totally unusable. And here's another classic one. Same good-looking screen on the left. But on the right, we have a scattered issue. The whole thing has just exploded. Buttons and text boxes are thrown all over the place. Remember, it's the exact same app, the exact same code, just running in a different environment causes this total meltdown. Now, even with all of this insane testing, sometimes a bug still makes it through to us, especially with things like hardware driver updates. But when that happens, you actually have a secret weapon. Seriously, think of it as your own personal emergency undo button. It's a feature built right into Windows called Driver Rollback. Okay, so a driver is just the little piece of software that lets your computer talk to your hardware, like your graphics card. If a new driver update makes your screen start flickering or acting weird, this feature lets you zap it and go right back to the old one that worked perfectly. And the best part is, it's surprisingly easy to do. You just pop open your device manager, find the piece of hardware that's acting up, right-click and go to its properties, head over to the driver tab, and just click that beautiful roll back driver button. It's a super powerful fix to have in your back pocket. Which kind of leaves us with one final big question. In this world where new devices are coming out literally every single week, can all this testing ever really be enough to catch everything? Or in our messy, complex digital lives, are we always going to need a good old-fashioned undo button?